everyone, welcome back to my Unity open world tutorial series. So in this episode we are going to see how to give inputs based on the direction we are looking at. That means when I press W or move forward button while I looking back, the character will go back to the direction I am looking at, and when I press S it will come towards the camera. So similarly it works on D and A as well, like this. So at this point we haven't still worked on animations, so that's why this character don't have any animations yet. We will work on them later. So yeah, for now, for today's episode, this is the problem we are going to tackle. Alright, so now when I press W key, the character moves like this, and when I press S, the character moves back, and with D and A this happens. But let's say I look at this direction and press W, so still the character is moving to its forward direction. The character is not considering the direction I am looking at. So yeah, so how do we rotate our character to the direction we are looking at? That's the problem we are going to address today. Right, let's open our character player input class. So in the player input class, this is how we add the input. Through the add moment input method I have defined inside my character class. So here we don't consider the direction we are looking at, so we have to consider that. Right, so let's draw some diagram to understand how I should do the calculation in order to give proper inputs based on the direction I am looking at. So yeah, let me take a screenshot from this direction like this. Can we get it with the camera? Right, let's take it with the camera. What's this one? I don't need it. Okay, let's take a screenshot here so that I can explain it properly. Let's go to Photoshop. Right, so now this is the direction camera looking at the moment. No, this is the character's direction at the moment. Alright, and yeah, now the camera's direction is also aligns with the direction of the character at this point. So when I use W to move forward, since I am looking at the same direction as the character, the input matches. So W moves this way and S moves backwards. So yeah, we don't have a problem there. So the problem happens here. Let's say, yeah, let me look at this way. and let me look at it like this, and let's pause the game here. Now where is the character? Why is it all I'm not sure why is it all white. Okay, anyway, here the camera is right here. Yeah, let's take another screenshot of this scene. Okay, and now yeah, let me put it aside. Right, now in this case the character's direction is same as before, like this, and the camera's direction is this way. So when I press W should apply along this red line. W means the forward movement direction, forward movement input. So yeah, so how do we apply that movement to the character? So for that we have to consider the component of this W vector, which creates with this blue line using the angle here. Let me call it A. This is too large. If the angle here is A, then I should add W cos A. This is the component of this moment input. I should add along the forward direction of the character, and similarly we would have a component of the moment input caused by this W in along this axis as well. So this would be W sine A. So I'm sorry about my bad handwriting, so but I think you get the idea. So you have to consider the sign here. I mean, like, it is a negative, it is going to be negative or positive based on the direction, based on the angle. But yeah, that's how. So, and also when you take D or the horizontal axis input, you have to do the same thing here. So in relation to camera, W or the horizontal axis is going to be like this. So which makes a right angle here. So this is going to be the horizontal input axis. Let me call it H. So I should have called it V here. Oh, well, actually, yeah, this one. So here also you have to take, if I call this angle B, H cos B along the forward direction of the W, forward direction of the character, and F sin B along the right direction of the character. So yeah, that's basically what we have to do here. So right now we have to find the angle between the characters forward and the cameras forward. So how do we do that? That's what I'm going to figure out next. So first let me create, in this character class, let me create a reference to the camera controller. So let's do it like this: public camera controller, camera controller, and then here, yeah, I'll define there, yeah, here I'll define a private function to return the rotation of the camera. Oh no, we don't need a function. I'll just get the rotation like this: camera controller get rotation. Or we can just use the transform. Now we have to use the object camera controller transform forward. Let's assign this to a variable like this: vector3 cam fwd equals, yeah. Alright, now similarly let's define another variable cam right, and let's get the right angle as well. Then well, now that I think of this, I think there is a much simpler way to do that, which does not involve all these calculations. So yeah, let's try another way. So yeah, this is what I'm thinking. So using the forward input, let's define, yeah, let me define another vector. I'll call it target location. Okay, target location equals forward, yeah, let's just go with the forward multiplied by camera controller transform dot forward. Here we should always make sure that this target location stays in the character's level. That means it shouldn't either go down to the ground or go up in the sky, but yeah, we can deal with that later. Okay, right, so yeah, this part, and then target location plus equals right into camera controller dot transform dot forward, sorry, dot right. Okay, now this is the target location we should have, and then let's define a unit direction vector like this, vector3. Okay, now we need another vector. Let's call it vector3 velocity equals target location minus transform dot position, that means current location, and normalize it. So this gives us the direction vector that we need to have in order to go to that target location. So instead of this one, now let's use the velocity. Okay, I should have defined this here. Let me make it private. So we don't need it. Okay, now let's see what happens. Okay, that's weird. Well, yeah, and we should set a value for the velocity only if we have something larger than 0 for something other than 0 for the forward and right angle, right input. So if if target location dot magnitude larger than 0, we should set the velocity like this. Otherwise we should set velocity to 0. This fix that bug we had. Let's see. Okay, no, actually I made a mistake here. So the velocity, so with this one, this is the velocity. This is actually the velocity I'm getting, not, I don't have to do this part. So the target location is the velocity. So this name is wrong. So I could use velocity all for this. So let me rename this. Press Ctrl R twice. I'll call it target, no, translation. So here, instead of doing this minus part, translation dot, yeah, actually that's all we need, only the translation. Now yeah, let's see now what happens. Okay, with W we move to right, with S we move to left, and with D we move back. So with A we move back, with D we move forward. Okay, so we have, yeah, we have messed up a little bit here. This first input is vertical axis, yeah, forward. Sorry about that. So let's quickly fix it. So it should be the first one. The next parameter should be the horizontal axis. Let's play. Okay, now it works perfectly. With S we can move back, with W we can move forward. Everything is perfect. Other than this, I can go upward into the sky and downwards into the terrain as well. So we will fix these problems when we use physics-based movement, but for now, as a quick solution, let's do something like this. The character in the translation, I'll set translation dot y to 0. So this will make sure that my character do not go upward or downward. So right, cool. Okay, now the movement input is working in relation to the camera. So that means if I press W while I look at this way, character goes like this. If I press, character goes back like this. Alright, so yeah, I'll stop this episode at this point, and the source code for this code will be soon available through the Patreon, and the download link will be in the description below. And yeah, thanks for watching. So let's continue to improve this system. Then see you in the next episode. Goodbye.